items, the forklift and the drivetrain. With the forklift, what we wanted to do was take more than one ball at once because we figured that was the best way to maximize points, especially since we didn't know exactly how long it would take for a robot to make one trip up and down the board. And the other part is our drivetrain, which is a two-wheel drivetrain, and we're using the rear wheels for that.
So strategically, we thought of a few different methods in which we could approach this project. At first, we wanted to figure out how to maximize the number of balls we could carry per trip, and so we were thinking about putting a trunk in the back of the robot so that we could carry multiple balls at once without having to actually lift them up one by one. But then we realized we wouldn't have the space requirement to do that with the 12 by 12 requirement, so we thought, okay, how can we maximize the balls per trip using either a forklift or a claw? We ended up going with a forklift because it would be easy to carry two balls at once, and we could maximize the points per run and lift them up relatively easily.
Oh hey, didn't see you there. Our forklift consists of two acrylic pieces that fit together in a T-shape that act as a rail for the forklift block. The forklift block is 3D printed and specially designed in order to cut the balls in just the right way. On top of the forklift is a pulley system that allows the fishing line to pull the forklift block up and down using one of the gearboxes.
Now, let's take a look into the wheels and the gear train.
So the wheels are a 2.5 radius wheels made of acrylic, and we have a hexagonal axle hole here so that the hexagon can grip the wheel while it's spinning. And then we also added an 1/8 of an inch layer of silicone for traction. And we have these divots here so that they could have grabbed into the silicone while we were molding it.
So for our forklift, we used 3 of the gearboxes. 2 of the gearboxes were used for our back driving wheels and 1 of them for our forklift. Now, based off the fact that we knew that the ramp was 20 degrees, and based off of our known motor torque, we calculated that we need a gear ratio of 9, which determined the amount of space we need between our gearboxes and our walls, which is how we made the base. Overall, it was a very challenging and fulfilling part of the class, and was definitely our favorite part of the course. We look forward to seeing what we can do come competition day.